So let's take a couple of examples to see how to deal with a negative clippers. So let's say the voltage is, so maybe 5 volts, require a resistor and a diode facing that way, and also a load resistor. So let's just pick these values of resistors. All right, so I want you to go ahead and give it a try on actually drawing the output waveform across the load resistor. So that's usually how, so draw the output waveform across. All right, so that means if you actually connect an oscilloscope on the load, what you would usually see it, what voltage levels that you will see it, and so on. So what you should end up with is, so what you're going to end up with is 2.5 volts on the positive cycle and 0.7 on the negative cycle. So that's, yeah. Yeah, negative side, that would be 0.7. So that's a negative 0.7. So that's 2.5 volts right there. And this would be negative 0.7.
So do you want to put that at peak to peak at the end of it?
Not necessarily.
So, okay. So
Usually, when you see it on an oscilloscope, you would see peak to peak. But you don't necessarily need to read it as a peak to peak when you're drawing it. You can leave it on either side. So 2.5 volts is the highest on the positive side. Negative 0.7 is the highest on the negative side. So you can put it peak to peak if you want, but that's not really needed.
but if you did, it'd be 3.2.
Yes. Yep. So that should be the resultant waveform. So if you start with positive cycle, it's the same way that I'm going to analyze this, same as before. Since the signal is an AC signal, so if you're dealing with a positive cycle, since the orientation of the diode, where the cathode is being on the top, so the orientation of the diode would be reverse bias. Subsequently, the negative cycle would make it forward bias. So as indicated prior, reverse bias means we can get rid of the diode that makes the given circuit is a complete series circuit. So voltage on the load is, so that diode will be completely gone. You don't even need to calculate it, but even if you do, you will get a 2.5 because you have an equal values of resistance. We'll split the source into the half. Right. So whenever you see that, even if you calculate it, you will eventually get the same voltage. So when you're dealing with positive voltages, the voltage come out as 2.5 volts. That's what you will see. Complete positive cycle will pass out, but only with a reduction in the amplitude because of that prior resistor, because it's going to drop something as well. So when you're dealing with forward bias, the diode will have 0.7, but look at the orientation of the diode where the negative is on the top. So the effective voltage would be negative 0.7 volts because the negative is on the top. So So that's what you will see here as well as a straight line for the entire duration of that negative cycle. You will be at negative 0.7. So that would be treated as a negative clipper. So this is usually what is referred as negative clipper. But in either case, even if you consider positive clipper or negative clipper, what is the clipping level? What is the clipping voltage level? Always going to be 0.7, right? So far, we only talk about a couple of circuits, so it's always. So, but if you want to change the clipping level, because in most of the applications, you don't always need a 0.7 volts clipping level. So you may require something different, or maybe required to adjust as needed. But if you use only diode, you only get that 0.7 volts. If you use silicon-based diode, if you use germanium, you will get what? 0.3 volts. So the next continuation to this particular clipper is usually, okay, before we get to it, this is some interesting circuit right here. So before we talk about how to adjust the level of clipping, what do you think this circuit does? Okay, to a what level, if you say so? Again, exactly the same way. How do we analyze it before? You start with positive cycle, see what happens. If you start with negative cycle, see what happens.
It's always going to go with the easiest path.
So go ahead and draw the signal on your note, see, and then we can compare it. So positive cycle, what will happen?
You're going to forward bias D2.
So the D2 would be forward bias. That means
You get 0.7.
D4. So you have 0.7 on D2.
No, yes, you will.
You have 0.7 on D2, but what about D4? So D4 will be open. So if D4 will be gone and you have only D2 and D2 has 0.7. So what would be voltage on the R1?
0.7.
Since the D2 is appear to be parallel to R1, so you will see that positive 0.7 right here. What will happen for negative cycle? For negative cycle, the D2 is reverse bias, but D4 is forward. That means it has 0.7, but the negative is on the top. So what you will be getting is negative 0.7. Yeah, and they're not going to cancel out to each other. Yes. It's an AC signal. You cannot combine those two cycles together. They are their own cycles. Reverse bias is implying the open side of the diode. Right? Reverse bias means that diode will be removed, but you have another diode still intact. Correct? So for example, if you say D2 forward, right? So D2 forward meaning that it's going to have that 0.7, correct? Whereas D4 is reverse. Reverse means it is a open, and you have your R1 right here.
And all of this is with, all of this is positive.
Positive 0.7 under positive cycle. For which one?
For this.
For this circuit? So for positive side, you will get a positive 0.7. Just like this, shown here, correct? So where you have that R1, R2 right there and your AC signal right here. But if you talk about negative cycle, so this is when the signal is being positive. So when you talk about negative half cycle, the D2 would be reverse bias, which means an open, but D4 would be forward, where the negative is on the top. Negative 0.7. Yep. So that's your.
Understanding of it, which I understand how it's, but I just got the dialogue correct. Dialogue part of it.
All right,
So I'm with you.
go back. All right, so that's pretty much that. Usually when you have two diodes back to back in parallel, you would expect that both sides will be clipped accordingly. But even in this case as well, the clipping level you always get is 0.